So again, I should have this before, but this first one is when you're buying stuff, you're selling stuff, or you're filling items. So like if you are your weekly vacation, or you're selling apples, or you're buying pumpkin pies, whatever falls into those categories, this is usually what those story problems look like. So first step is read it, underline all useful. The second step is defining your variables. Now, I will tell you, I'm not saying you should like make it so you're writing like a full paragraph. But when I define the variables, I would give you a heads up and say I would be descriptive rather than trying to do one word. I would try to do just something that makes it pretty obvious. So, for instance, and also when you're defining the variables, look at what they're asking. So it says, what's the cost of each type of pie? I've had people that say A is equal to pie. Well, yes, that is he. It's nice to say it's the cost of each apple pie. Because if you just say, hey, is apple pie, is that how many apple pies? Is that how much they weigh? So I think it does help to be a little bit descriptive when you define your variables. So I make A is equal to cost of apple pie. And P is equal to cost of pumpkin pie. You don't have to use correct grammar. If you literally just said apple and cost, I can live with that. So the third step is setting this up, and this is the part that I really need to make sure you guys know, because in my opinion, this is the difference compared to what we did before. We need those equations like we've been doing. So my first equation in blue. 3 apple pies and 2 pumpkin pies cost $52. So if you really want to look at this and think about this deeply, what you're doing is the total cost. Well, if you sold 3 apple pies, you take 3 multiplied by how much it costs for an apple pie. Well, just hypothetically speaking, if an apple pie was $10, you bought 3 of them, you pay $30. You take 3 times 10. Well, the whole thing is you know what the apple pie costs, so it's 3 times A. We add to that 2 multiplied by P because we're buying 2 pumpkin pies. So how much do you spend on pumpkin pies? 2 times whatever a pumpkin pie cost. That's equal to $52. Next one, Becca sold 6 apple pies, 3 pumpkin pies for $87. Now, again, most of you guys, especially once you get started with this, you won't have to think about it this deeply. But again, I think it helps to kind of know what this is. So to get the total pumpkin pie, you're adding the total. How much made on pumpkin? Well, how much did they make? Well, they sold 6. It's 6. 1 apple pie. Then 3 times how much it costs for 1 pumpkin pie. That's how we set up our variables. That's the important thing. That's what I'm going over. There are questions on the test, but that's all you'll have to do. Just set it up and forget it. Now, again, for today, I'm going to, while we're doing them together, I'm going to solve these. I know a lot of people act like elimination is just the best thing, and for this one, yes, elimination works out really well. However, there are problems that you'll do that substitution is a lot easier than elimination, and you'll just have to see what it looks like when you get it set up. So to solve with elimination, I multiplied them by -2. So I have a lot of space, so I'm going to say that if 6a minus 4p is equal to 52 times -2 is -104. The other equation didn't change at all. 6a plus 3p is equal to 87. When you add these together, to cancel, -4 plus 3 is -1p, and -104 plus 87 is -17. If you divide both sides by -1, your pumpkin pie is 17. Now, the good news with this is that once you have one of your variables, what one of those pies cost, it's usually pretty straightforward to find what the other variable is. This one's a little bit more of a struggle, but a lot of them are pretty straightforward to find out what the other thing is. But you can always do it the same way we've always done it. Plug it back into one of your equations. So I'm going to plug it into this one. Looks like the easiest one. So 3 times A plus 2 times 17 is equal to 52. Sorry, I couldn't fit that in there. That's 3A is equal to 34. Sorry, not equal to. 3A plus 34 is equal to 52. Subtract 34 from both sides. Sorry, I didn't do that. I ran out of space. Then divide both sides by 3. I get my A is equal to 6. So I solved. I got P is equal to 17. A is equal to 6. I want you to put that in a brief description or a sentence or whatever, because again, I have a lot of students that then, even when I want a description, a lot of students will say, so she sold 17 pumpkin pies and 6 apple pies. That's not what we're asking. We know how many pumpkin pies and apple pies they sold. We're asking how much each one would cost. So when you're writing your sentence, if you figure out how to write it, literally just go back. What is the cost of each type of pie? And answer that question. And again, the way I would like you to look at this is, if you were in the situation and one of your friends said, so what was the cost of each type of pie? How would you answer that question? And sometimes you maybe have to be a little bit more descriptive, but for the most part, just answer that question. So how much does it cost for each type of pie? I would say pumpkin pie costs $17. Apple pie costs $6. It's not a sentence. Yes, question. So did you say A equals for apple, like that? Yeah, I can live with that. I mean, if we're being honest, I'd rather you have it, but I can live with that. But if you just have, the reason I wrote it up there, if you just have A is equal to $6, I do want more description than that. But yeah, you don't have to do a long sentence. You don't have to do anything crazy. Just, again, the bare minimum to answer that question and be specific about it. So go on to the next one. And again, just to save some time, because I know this one's going to be another one that in a block day, we easily finish this. Today, I hope we finish it. And again, this is a really weird lesson split up into 2 days. So to save a little bit of time, go ahead and do this one, 1B. Don't solve it. Just go ahead and set it up. I'll put, I'll define the variables. So while you're reading this, if you want to do this. So I'm there to help you out. Go ahead, do this one. Again, just set it up. If you have extra time to solve it, by all means you can. That'd be great practice. Just set this one up as well. All right, so I did step 1 and step 2 for you guys, the variables, but I also highlighted all the important information. And again, this is when you look at the style and it says buying / selling / filling items. This is an example. You're filling vans and buses. I've seen it before where you're filling barns and sheds. It all just depends. So 10 vans plus 3 buses is equal to 208. 5 vans plus 12 buses is equal to 587. That's all I need for your answer. And you don't have to solve if you wanted to. It wouldn't be the end of the world. But again, all that means is if it's 10 vans, V is the number of students that fit in each van. So 10V is how many students were in the van for that school A. The B is how many students are in a bus. So 3 times B is how many students total were in the buses for school A. And again, make sure you're looking at what they're asking. How many students does each type of vehicle carry? So again, that's why I said the V is the number of students per van, B is the number per bus. And again, if you were trying a short description, you would just answer that question. How many do each type carry? Vans carry this many students, buses carry this many. That's all you'd have to do. Doesn't have to be anything crazy. Any questions on those? I really like those because I think they're a little bit more difficult to get to that step, but also it's a lot easier to get that step. I think it's a lot more black and white where it says 10 vans, 3 buses, and then gives you a total. 5 vans, 12 buses gives you a total. I will also point out this is always going to be for the most part. But notice it does say that each van and each bus carry the same number of students. Obviously, that's pretty important because if you have 10 in some vans and 3 in some and 5 in some, it's going to be a lot different. Okay, moving on. This one is, I think, is one of the easiest to solve once you do have it set up, but to set it up, I think it's a little bit different, or a little bit more difficult. So you're comparing things, comparing 2 things together. So these problems look like this. 2 friends were discussing their life and how combined their ages in years. Older of the 2, I may be 7 than you, but I'm young at heart. Now notice this one says, how old was the older person? Now, what they're asking, you might actually save yourself a little bit of time if you're solving it. For me personally, I just solve and find out both ages because, and for me, when I was a student, it was just way easier to solve it and do it the same way that I always know how to do and then answer the question than to try to figure out which is which and take some time to do that. But again, whatever works for you is good. My variables for this one, I try to avoid this. So if you want to use X and Y, it's not a bad idea. But O is the age of the older person. And then so I'm going to put Y is the age of younger. Now, I try to avoid O as a variable because a lot of times you get students get confused and think it's a 0. So if it's 3O, they think it's 30. So just be careful of that. But again, I give those to you on the test. If not, you can make them whatever you want. So honestly, I probably would call it X1. So read and highlight, then define your variables. Now, this is the hard part of this. Now, one of the things that I think is really interesting is the first equation. I always have a lot of students that struggle with it, and I don't understand why. Because all it says is combined their ages total 99. Well, if you're combining 2 things, what do? You're adding them. So how do you find the ages of 99? You just take those 2 ages and add those together. O plus Y is equal to 99. That's it. Out of these examples, there's a lot of these story problems that start out like that, where you just take your variables and you add those together, and that gives you a number. You'll see what I mean in a second, because when we do more of these types, you'll see that. But combine their ages are 99 years. Now, this is the hard one. The older one said, I may be 7 years old, but I'm young at heart. Well, obviously, the important thing is 7 years older than you. There's a couple different ways to look at this, but here's the problem. Is the answer this? The older person, 7, is equal to the younger person? The older person is the younger person's age plus 7. Those are 2 options. Most of you guys, most of the students I have can get to either of those. So one way to look at it is if it says if the word is, that's an equal sign. Is 7 years is older person is equal to the younger person plus 7. The other way to think about it is who would have, if you look at both these scenarios, which one of these variables would be bigger? Well, the first one, oh, you're adding 7 to it, so that makes y bigger. Well, how would the person's age be higher than the older person? So you know that can't be the truth. That can't be it. No, that's not a great method, but that's one of the things that I found that helps. If you just sit back and check to see what one has to be, what one should be a bigger number, and then what one is your equation saying is a bigger number. It's definitely not. So it's O is equal to the younger person plus 7. The older person is 7 years older. Again, on the test, are going to be done like this. Some of them on a worksheet are like that. We're going to go ahead and solve this. This one works really well with substitution. Since O is equal to y plus 7, I just put that in for this O. So it is plus 7, then plus y is equal to 99. Plus 7 is equal to 99. If you 7 for both sides, 99 minus 7. And if you divide both sides by 2, 46. So the younger person is 46. So what's the older person going to be? Well, this is where it's actually pretty easy. To 99, 99 minus 46, you could use that. Or you know the other person, or sorry, the older person is 7 years older. So that answer, 46 plus 7, is that older age. Writing your answer out, I would just say the older person is 50. Younger person, oops, okay, is 46. It doesn't have to be grammatically correct. It doesn't have to be full sentence. I don't care. Just as long as I can tell you guys know what's happening. And I don't remember, I don't think it's this test, but I've given a test before. I think it was when I was at Goshen, where a lot of people that missed it, when they finally got their answer, they had that the younger person was actually older than the older person. So make sure you double check that. Go ahead, do number 2B. Again, just set it up. Don't actually solve this one. And we may have to start going to that totally just to make sure we're done on time. All right, real quick. Hopefully not rushing you, but we only have 20 minutes left, so I want to make sure we get done. So again, all the problems that I give you that have to do with comparisons, I'll take a step back. As a math person, I don't like to say 100%. So most of them, I think all of them, but definitely most of them that have to do comparisons, always start off the same way, just like the last one. They rode a total of 67 miles. So if you take the number of Miguel plus the Brandon, that is equal to 167. That's the total. Now, Brandon complimented Miguel for outriding him by 17 miles. Now, this is the one that a lot of people struggle with. Since Brandon complimented Miguel, which one rode more miles? Well, Miguel did. That's why Brandon's complimenting him for outriding him for 17 miles. So Miguel should have more miles. So Miguel is the same miles as Brandon is, but you add 17 to Brandon's. He outrode him 17 miles, so it's Brandon plus 17. Again, most students, it's just because they did the other way around. They say Brandon's equal to Miguel plus 17, and that's what I'm saying. If you take a double check, just to make sure, so which one of those should be bigger in these scenarios? It should actually be bigger because you take Miguel plus 17, so Brandon has more miles. We know that's not the case. So if you ever aren't sure, again, best way to do it probably, but that's the best that I can come up with. So that ends up my answer for this one. Okay, moving on. Style 3 is probably one of my favorite ones, and I'm just going to set this one up because, again, I'm basing on the fact that you guys probably know how to solve systems by now, or yes, I should maybe say that if you don't, then maybe this is probably not where you're going to learn it. But this is selling tickets. So this is a very typical system story problem you'll see in Algebra 2, probably in Algebra 1 too, when you're buying adult tickets and children tickets to a circus or a theater thing or movie tickets or something like that. You're buying tickets and you usually have two separate groups of people. 3 by 3 to go through that. A group of 15 people. One of the other things I found with this type of problem is a lot of times they trick you by not putting the number. So a lot of students, when they read, they don't actually read it. They look for the numbers to highlight, but then they miss 15. So maybe a group of 15 people went to the circus. Tickets per adults, $9 per children. The group spent a total of $100 on tickets. How many adults, how many children in the group? So obviously the variables would be A is the number of adults, C is the number of children, doesn't seem like it's a lot of information because they didn't give us two different equations. So far, both those other ones, you could kind of see one equation and then a second equation. Well, this one, it's kind of all jumbled up together because they start with telling us 15 people, then they tell us how much it is, and then how much the total is. The last one, if they had 15 people in their group, 8 adults went, don't they have to be either adults or children? The number of adults that went and the number of children that went and add those together, that's how many people went in this group. That's got to be 15. Again, just like the last example that I gave you, the last style, I think all of this, most are going to start with that, where you take it together, get the total amount of people that went. I think all of them do, but again, as a person, I am suspect of 100%. How about this 163? Well, we're going to go with the 16 and the 9. So if it was $16 for every adult, so you take 16 times how many adults went, plus $9 for each child, so how many children, that equals to what they paid. This is one of the problems that some students struggle with. I get it. The first equation is take the two variables, the total, that's the amount of people that went. And then the next equation, you use the amount they paid per ticket to equal the total amount they paid. Go ahead, do number 3B on your own. I'll put the second. Again, we're not going to solve them from here on out. There's one type of problem that I'll solve. But I want to make sure I have time for that. So go ahead, set this up. And again, this is adults and students. Adults and youth, so whatever variables you want. All right, so those are the two equations that I got for this. If you did not use y for youth, c for children, that's fine. Your variables, again, on the test, I gave you what variables I would like you to use. If you want to be super stubborn and use different ones, I guess that's on you. But when you make your own variables, you can literally put whatever you want. If you want to draw like a little upside down house with a goat living inside, that's fine. You can do that. Depending on how big you're writing, I wouldn't recommend it, but whatever goes. All right, the next style. Now with coins, I should start out with saying, how do I want to say it? Quarters are 25 cents. And you can write this somewhere else if you have more space. I just don't. Quarters are 25 cents. Dimes are 10 cents. So $0.10. Nickels is 0.055 cents. And pennies are $0.01 or 1 cent. Oh, you guys know that already. But with this day and age with Venmo and credit cards, I've had students that get literally confused about dimes and nickels. We're not here to judge. It's the same. Now, the reason I use is because it doesn't seem like they give us enough information. So Caitlin was counting her spare change. She realized all she had was nickels and dimes. She must have thought of that. She had a total of 51 coins, but only had $3.50. How many dimes does Caitlin have? So when you look at this, it doesn't look like we have enough information. We have that she has 51 coins, and we have that it's $3.50. Well, the thing is, the information that we know that they don't have to give us is what I just wrote up there on the board. That quarters are 25 cents or $0.25, dimes are 0.10, nickels are 0.05. So if all she has is dimes and nickels, again, the variables, D is the number of dimes, N is the number of nickels, coins total, number of dimes plus the number of nickels, that's how many total coins she has. Remember, I told you this from the very second style we did, that a lot of problems have by adding them up, adding the variables, just the plain variables with no numbers, and that equals the total. This is the third style that's like that. But then the hard one, then she has $3.50, a total of that. Well, if each dime is 10 cents, then there's two ways to do this. What I recommend is to make sure you put 0.10 dimes, 0.10 times D. Nickels is 5 cents, so make it 0.05. Don't put 0.5, that's 50. And that equals $3.50. So this is one way to do it. And I'll be honest with you, every year I do this, even as I'm teaching it, I'm not sure if that's the easier way or not. It all depends. So the other way to do it is instead of looking at it as dollars, you can look at it as cents. So you can say it's 10 cents for each dime, 5 cents for each nickel. The reason I go back to a lot of then they turn around and say that that's equal to 3.5. Going for the sequence, they all have to be cents. Decimals, that's fine. You just end up with 350 rather than $3.50. The way I recommend, I guess I recommend that blue way, but the way it works. Stick with this, and the reason I come back to this, and at least I'll start solving this. To use elimination, you could use substitution as well. But with elimination, we just need two things to be equal but opposite. So it's really nice because I know that decimals, and that's really weird, but if I just multiply this top equation by negative 0.10, then we'll have my dimes as negative 0.10 D. My nickels are negative 0.05 N is equal to, and then I'll do for 51 is 51 multiplied by negative 0.10. Put in your calculator, that's negative 5.1. Now all of a sudden, it's really not too bad All right, these nickels should be negative 0.10 because you multiply n by 0.10. Now, all of a sudden, to use elimination isn't too bad. Your D's cancel, and everything else, yeah, you have decimals, but you guys also have a calculator that does have a decimal button. So negative negative 0.10 plus 0.05, put in your calculator. Whoops. That gives me negative 0.05n. 0.1 plus 3.50 is negative 1.6. And then you just divide both sides by negative 0.05. I'm going to stop there for this one. And we'll probably move on to the next one. You guys should be good from here. But again, that one, it's a little bit more difficult to solve because you have decimals. The other option would be, obviously, like I said in the other one, make it 10 cents for dimes, 5 cents for nickels. You just have to remember that $3.50 is actually 350 cents. So if you want to do that way, that's fine. In my opinion, if you're me, I'm using my calculator anyway, so it doesn't make much difference. I'm going to skip the one that you guys do on this one. I apologize for timing. But the last one we're going to do is 3x3 systems. Most of the 3x3 systems, in my opinion, the first two equations are usually pretty straightforward. The third equation sometimes is straightforward, and sometimes you need to do a little bit more work. Frank's local dinner, the Hunger Man comes with 2 burgers, a drink, and fries. Well, a drink is 1 drink, fries, 1 fries. That costs $13.75. 2 burgers, 2 fries, 2 drinks is $17.50. This is the hard one. A burger costs twice as much as an order of fries. You'd use to solve. So obviously we have here. We have D is the cost of drinks. D is the cost of burger. D is the cost of drinks, or a drink. The F is the cost of fries. You just set it up like we did before. 2 burgers plus 1 drink plus 1 fry is $13.75. We've done that before. That's not too bad. The next one, same thing. 2 burgers, 2 fries, plus 2 drinks, $15.50. Now, I will take a little sidebar and say, if you were to solve this one, you should burgers are first, then all your drinks or whatever order you want to go in. So you might want to flip these around if you were solving it. We're not solving this, and I won't have you solve one like this, so don't worry about that. The last one, a burger costs twice as much as an order of fries. So again, hopefully a burger is twice as much as the fries. So a burger is 2 times the amount of fries. People have missed this, just do it the way around. Fries is 2 times burger. Does that make any sense? If a burger is twice as much as fries, the burger is more expensive. This one says the fries are more expensive. So hopefully, if you need to write both those down and get rid of one, you can. But a burger is twice the amount of fries. I would love to have you solve one like this, but I don't want to put very many 3x3s on the test because they take forever. If you solve one and this one, even if you can solve, then it should be good after this step. Monday will be practice test. A couple people will ask when the practice test is due. It's due the day of the test. It always is. So that's due on Tuesday, but you can get as much done as you can by Monday. Questions. My goal is to, if I haven't taken the quiz, do the quiz on Monday. If you have taken the quiz, I want to hand that back on Monday, go over that briefly, and then take any questions on the practice test. There is a video practice test. It's video, but again, you can fast forward, you can pause, you can do whatever you can do.